Hello everyone. We're going to try to add and subtract radicals. So, you can only add or subtract like terms. In order for radicals to be considered like terms, they have to have two things. They have to be the same root, so they need to both be square roots or cube roots, and they need to have the same inside. And then to combine them, you add or subtract the coefficients on the radicals, not the inside of the radical. So let's look at an example. Okay, I'm going to try to simplify this expression. So I have square root of 2 plus 3 root 2 plus the 5th root of 2. So here I see a ton of 2's. Are these all like terms? The answer is no, there's only 2. These two are like terms. They have the same root and the same insider. Here, this has the same inside but different root. I'm not going to be able to combine this with anything, but I can combine these two things. Remember, you can always put a coefficient of 1 out here. You have 1 root 2. So to combine these, I get add the coefficients. 1 plus 3 is 4, but leave the inside alone. 4 root 2 plus, even though this is an unlike term, it doesn't disappear. Continues on throughout the problem, and we got it. Alright, let's look at a more complicated one. Okay, let's take a look at this problem. I've got 2 root 8 minus root 18. Alright, can I do anything right now? No. As currently constructed, these guys are unlike terms. They are both square roots, which is nice, but they have different insides. So what I need to do is I need to take each term and kind of simplify each term, and hopefully I can make them turn into like terms. So this guy has a 2, so I have 2 square root of, let's see, I need a perfect square in 8. Well, that's going to be 4 times 2 minus square root of, we need a perfect square in 18, and that's going to be 9 times 2. Alright, which equals, let's see, this 2 is out front. This is 2 times this, so times makes sense. Square root of 4 is 2, and this 2 is trapped. Minus stays minus, square root of 9 is 3, and this 2 is trapped, which is kind of good news since I'm seeing some like terms that are going to happen. 2 times 2 is 4, so I got 4 root 2 times 3 root 2. These guys are definitely like terms. Keep the root the same and the inside the same, and then subtract the coefficients. 4 minus 3 is 1. We get 1 root 2, which is just root 2. Okay, let's try one more. Alright, let's see what we can do with this. Alright, this is a monster. I got variables inside these radicals. Right now, they're unlike terms. They're both cube roots, but they don't have the same inside, so I know I need to simplify both radicals first. Okay, and remember, we got ourselves cubed roots here, so don't look for squares, look for cubes. So I got a 9. Cube root. Okay, I need a perfect cube in 24. Ah, 8. 8 will do. 8's a perfect cube. So 8 times 3, work the number first, then work the variable. Same way, perfect cube, leftover stuff. X to the 4th. Is there a perfect cube in there? Yeah, it's x cubed, and then I got 1x left over. Minus stays minus. Cube root, still cubed root. I got 81, so be careful. It's cubed roots, so don't do 9 and 9. Those are squares. We need a cube in there. And that cube is 27 times 3. Same thing, x to the 4th. I'm going to rewrite that as x cubed times x. Perfect cubes, leftover stuff, etc. Equals. Alright, this is 9 times the cube root of 8 is 2, and the cube root of x cubed is x. And then what's left in there? The 3 and the x. Minus the cube root of 27 is 3, and the cube root of x cubed is x. Don't lose that 3. Cube root of what's left in there? The 3x. And now what do you know? We have like terms. Equals. I multiply these first, multiplying before I do subtraction. This is 18x cube root of 3x. Oops. Minus 3x cube root of 3x, and now I'm set. Now I'm going to do a subtraction. So we have like terms here. 18x minus 3x is 15x 3x. Oh, careful. Still have that cube root. And we got it. And we have earned a smiley face. Alright, that'll do it for this video. On to the next one.